Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 4, Lesson 5, and we're going to study the trapezoid and the kite. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So you can see over on this picture on the right that the two parallel sides have those extra arrows on there. Those are the bases of the trapezoid. The other two sides, the non-parallel sides in a trapezoid, are called the legs. You can also have something called an isosceles trapezoid. And in an isosceles trapezoid, the bases are parallel, so you have parallel bases, and you have congruent legs, which means just like an isosceles triangle has two congruent sides or equal sides, an isosceles trapezoid has two equal sides. So you can see here GF and HJ, they have that extra tick mark on them. So they are congruent to each other. So this is an isosceles trapezoid. One pair of parallel sides, one pair of congruent sides. And both pairs of base angles are congruent. So let's fill that in also. And what I mean by base angles is the two angles that touch the same base. So like angle F is congruent to angle J, and angle G is congruent to angle H. Those would be the two different pairs of base angles. Additionally, in an isosceles trapezoid, the diagonals are congruent. So we now have three shapes that have congruent diagonals. Remember the rectangle? In a rectangle, the corners were all 90, and the diagonals, remember across and across, those were congruent diagonals. And then remember in the square, same thing. That's not a very good square, but the two diagonals are also the same length in a square. And now the isosceles trapezoid. In an isosceles trapezoid where you have one pair of parallel sides and one pair of congruent sides, the diagonals are congruent. Trapezoids can also have what's called a midsegment. The midsegment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So in other words, V is in the middle between Q and U, so these are the same length, and S is in the middle between R and T. It's a midpoint between R and T. And then that segment, VS, is called the midsegment. So let's just make a note of that. Midsegment equals segment VS. Now the midsegment of a trapezoid, it's going to be parallel to the bases. So in other words, all three of these segments are parallel to each other. And its measure is 1/2 the sum of the lengths of the bases. So in other words, the distance from V to S is going to be if you add the distance from Q to R plus the distance from U to T, and then divide by 2. Take half of that sum. Number 1, find the measure of angle D. Well, I think quadrilateral ABCD is an isosceles trapezoid. It has one pair of parallel sides and then one pair of congruent sides. So this is definitely an isosceles trapezoid. And in an isosceles trapezoid, the base angles are congruent. So in other words, C and D should be the same size. So angle D will also be 101 degrees. And then angle B, well, think about this, you guys. These are parallel to each other, and this cuts through like a transversal. So in other words, this 101 down here and this angle up here, those are consecutive interior angles. And consecutive interiors add up to 180. So 180 minus 101 is 79 degrees. Number 3, JKLM is an isosceles trapezoid. The measure of JML, which is this angle down here, is 130. And from K to N is 6.7 feet. From M to N is 3.6 feet. And we are supposed to find the following. Part A, the measure of angle MJK. MJK is this angle up here at the top. And so remember, if this is an isosceles trapezoid, which it says it is, these are parallel. And so angle J and M should add up to 180 because they're consecutive interiors. So 180 minus 130 would leave 50 degrees for up here in angle J. Next, JL. Well, if it's an isosceles trapezoid, diagonals are congruent. So from M to K, we would add the 3.6 plus the 6.7, which adds up to 10.3. And so if one diagonal is 10.3, then JL must also be 10.3. Make sure you label because they labeled, so we should have feet. Number 4. Given DFGH is a trapezoid with bases DF and GH, if DF is 5 and GH is 17, find the midsegment. Will you please pause the video and try to draw this and label all the parts? When you're done, unpause. Okay, so here's my picture. Notice DF and GH are parallel. One really important thing is how I labeled it. DF, G. So I'm going around the shape lettering. I didn't jump over to the far left again. So DFGH went around in a clockwise motion. It doesn't really matter if you go clockwise or counterclockwise, but once you start labeling your shape, you have to finish in that same direction. Go around it. We're supposed to find the midsegment. So if you find the middle of this side and the middle of this side and connect them, then that is what we are looking for, that segment in the middle, that green segment. So remember the formula. To get the midsegment, we add 5 plus 17 and divide by 2. So that's 22 divided by 2, which is 11. They did not label, so we do not need to label. In the figure, MN is the midsegment of trapezoid FGJK. Find the value of x. Well, if we add the two bases, 20 plus x, and divide by 2, it should equal the midsegment, 30. Now work backwards and solve it. So what I would do is I would first multiply by 2 on each side. What's going to happen is they will cancel. So then we're going to have 20 plus x equals 60 minus the 20, x equals 40. It kind of makes sense, right? 30 is in the middle between 20 and 40. Number 6. Quadrilateral ABCD has these vertices. Show that ABCD is a trapezoid and then determine if it's an isosceles trapezoid. Well, if it's a trapezoid, it has to have one pair of parallel sides. Now, to find out if sides are parallel, you have to know their slopes. Because remember, if sides are parallel, they will have the same slope. To do a slope, we can count rise over run, or we could also use the formula. So if you want to use the formula, remember it goes like this. It's y2 minus y1 over x2 minus x1. So feel free to use that, or you can just count rise over run. Like for instance, to get from A to B, if I wanted to count that, I would rise 2 and I would run 1, 2, 3, 4, 5, 6, 7, 8. So I rose 2, ran 8, so that has a slope of 1/4. Slope from C to D, it looks like I rise 1 and I go over 1, 2, 3, 4. So I rose 1, ran 4. Yeah, I'll write that down here too. Rise over run is another way to get your slope. So either way works. Let's do AD. So from A to D, I'm going to have to go down 1, 2, 3 and over 1, 2, 3. So it's down 3, right 3, which reduces to -1. And then the slope of BC. So here I would go up 1, 2, 3, 4 and over 1, up 4 over 1, which is 4. So you can see I have two sides that are parallel. AB and CD have the same slope. So I could just make a note. AB is parallel to CD because they have the same slopes. Segment AB is parallel to segment CD because they have the same slopes. Therefore, ABCD is a trapezoid. I have one pair of parallel sides. I'll just write that down. Because it has one pair of parallel sides. All right, now we need to determine, is it an isosceles trapezoid? Well, a couple of things we could do. We could find the lengths of the diagonals, or we could find the lengths of the legs. And if they're congruent, then it would be isosceles. Now, it's already marked on our sheet here. They want us to find the legs, AD and BC. Remember the distance formula. You're going to have to use this. You're going to use x2 minus x1 squared plus y2 minus y1 squared. Here we go. So from A to D, my points are right here. I just circled them, 5, 1, and 2, 4. So I'm going to go big square root. I'm going to go 5 minus 2 squared, and then 1 minus 4 squared. So I get 3 squared plus -3 squared, which is 9 plus 9, which is the square root of 18. And I'm just going to leave it like that because it's not a great number. You could change it to 3 root 2 if you wanted to simplify the radical. BC, let me just erase so we can see those points a little better. So BC, we're going to use our points over here. I'll circle them in red. And I'm going to plug them into my formula. So I'm going to go -3 minus -2 squared, and then -1 minus 3 squared. Remember, a minus changes to a plus. So -3 plus 2, really. So that's -1 squared plus -4 squared. When you square negative, it becomes a positive. So we have 1 plus 16, which is root 17. What do you think? Is it isosceles? We got root 18 and root 17. No, it is not isosceles. So I would say this: since the legs are not congruent, ABCD is not isosceles. Moving on to kites. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. So in other words, it has 2 pairs of sides that are congruent, but the congruent sides are right in a row. And you can see over here this picture of the kite. SP and SR are congruent. That's 1 pair of consecutive congruent sides. And then PQ and RQ is the second pair. Now, kites are kind of different. In a kite, only 1 pair of opposite angles are congruent. So in a kite, K and M, in this picture over here on the right, are not congruent, but angle J is congruent to angle L. So it's basically where the non-congruent sides meet. At those angles, you'll get congruent angles. The diagonals are perpendicular. Notice how they meet at 90 degrees. Perpendicular, or in other words, upside down T. The diagonal between the non-congruent angles bisects that pair of angles. Okay, so one pair of angles gets bisected. Angle A gets cut in half, and angle C gets cut in half, but not B and D. Those do not get bisected. So one pair of angles gets bisected. Also, one diagonal gets bisected. BD gets bisected by AC. So the distance from B to the middle here is going to be the same as D to the middle. One diagonal gets bisected. Number 7, WXYZ is a kite. Find the measure of angle XYZ. So we are looking for XYZ. We're going to try to find this angle. Well, one of the things I know is it's a quadrilateral. So in a quadrilateral, it has 4 sides, and 4 minus 2 times 180 is 2 times 180, which is 360. So in other words, the angles inside of this kite have to add up to 360. Now, if it's a kite, it's going to have one pair of congruent angles. So find where the two non-congruent sides meet. So here at the 121, and the one across from it, the Z, will be the same size. So now what I can do is I can take 360, I can minus out the 121, and the 73, and I can see how much do I have left. And it turns out I have 45 degrees left. So 45 degrees is going to be the measure of angle XYZ. Number 8, MNPQ is a kite. Find NP. So one diagonal gets bisected. So from R to P is also 8. Also, in a kite, diagonals are perpendicular. So what we have, if you look closely, we have over here a right triangle. Now, we haven't done one like this before, but I think you've heard of something called the Pythagorean theorem. We're going to study it more in depth later in this year, but I think we can do this, even though we haven't studied it a whole lot yet. We can do the Pythagorean theorem where you go 6 squared plus 8 squared equals NP squared. And so remember, it's A squared plus B squared equals C squared. Does that ring a bell? And it's used in a right triangle to find one of the missing sides. The two legs have to be your A and your B, and your longest side, or your hypotenuse, is your C. So 6 squared is 36, 8 squared is 64, and we want to try to find NP squared. This adds up to 100. And then what we do to get rid of that squared, because we don't want NP squared, we would just want regular NP, is we do this thing called the square root. And it cancels out the square. So you're left with just plain NP. And the square root of 100, technically it's plus or minus 10, but since we're talking about the distance on the side of a kite, it's not going to be negative, so we only need the positive. Please pause the video and try number 9. Remember, it's a kite. It has 4 sides, and so the sum of the interior angles is 4 minus 2 times 180, which is 2 times 180, which is 360. So if I take 360 and I minus out the 128 and the 72, then we are left with 160. And so angles F and H are the two angles that will be congruent in the kite. So if we take the 160 and cut it in half, we get 80. So angle F is 80 degrees and angle H is 80 degrees. So the measure of angle GFJ, if I trace that, is going to be 80 degrees. Okay, here's one more of those Pythagorean theorem types. If WXYZ is a kite, find ZY. Well, remember, if it's a kite, it's going to have diagonals that are perpendicular. So use this triangle right over here and set up the Pythagorean theorem. The 8 and the 24 are your A and your B, so it's going to be 8 squared plus 24 squared equals zy squared. So 64, 24 squared is 576, and then you add those together, so you get 640. And we don't want zy squared, we want regular zy, so we're going to take the square root. And you get kind of a yucky number. It's approximately 25.3 is zy. All right, I know that was a lot, so go ahead and try Unit 4, Practice 5. If you get stuck, send me a Schoology message. Have a great day.